So just we are seeing the procedure to draw a schematic and how to use KiCad, that is an open source software. So what I have done since the beginning, I have opened this KiCad as you can see from the screen, and then I see this option, a schematic editor. So I click here, and after that it's some old schematic is opening up right over here, so I don't want to go through it, so I will close it. Instead, I will click the file and create a new project. After that, I come to this flow folder where the KiCad has been installed, and I right click on the screen and create a new folder, called it click as, and let's say I say my files, the name of the folder, and I click OK. Now let's say this is my project one, and I click the save button, and it is asking me create a new project in this library, and it says you don't have permission to save in this location, contact the administrator to obtain the permission. Would you like to save in the Vinayak folder instead? Yes, so click yes, so it will save in the folder called Vinayak. So where is that folder? Right here in the local C driver, and in that you have this folder. So instead, otherwise you just click local C and maybe local D, and you have, let's say, click new folder and say my files KiCad, KiCad, and then you just save all your projects. So this is your project one, and click save, let's say. Yeah, so it now helps you do that. So now once you do that, you see it creates two files under the name project one KiCad Pro. One is project KiCad PCB and one is the schematic. So remember, this is for both schematic and PCB. So we double click the schematic file, it opens up this window, schematic editor. You see I'm hovering the mouse there, and a lot of different things on the right symbol panel. On the top you have a file, then edit, you have view, place, and inspect, tools, preference, and help menu. So now we are going to see what other things. For example, this is create, delete, and edit symbols. This is browse symbols for that one. This is create, delete, and edit footprints. Fill in schematic symbol or reference designators. This is for to perform electrical rule check. This is simulate the circuit in SPICE. So you have an option of simulating the circuit in SPICE. Run footprint assignment tool, and now generate a bill of materials. And this is open PCB in board editor. And the final one show the Python scripting console. Right here we see you can highlight the wires and pins. Here add symbol, add power symbol, that is ground, add a wire, add a bus, add a wire entry, and all these things are there. Now here so many other things you can explore. Now how to start? If I right click on the screen with the mouse, add wire, add bus, and that's the zoom. So now zoom is 100%, that is one. So let us first find out where to place the components. So we go place, add symbol, add power, and let's click add symbol. It is loading the symbol library, and it says that configure the global footprint library table. So since you are running the KiCad for the first time, it is giving you this instruction. So just keep it as recommended, copy default global footprint library table, click OK, and it is loading the footprint libraries now. Once that is done, you actually can see, you can choose the symbol for anything, for example, amplifiers, your logic gates. Then you have analog components and devices such as modulator, demodulator, etc. And schematic in the top, and in the bottom you have this PCB footprint also. You have analog ADC, analog DAC, analog switch, and comparator is also there. So for example, you see for some symbols you don't have a footprint there. So for example, no footprint specified. You have different ICs. For example, this is an operational amplifier. So I skip that, I go to place again, add symbol, and I see what comes here. So for example, I want to simply select the register. So I click this. So now it shows me 6 register network. So this is what I'm getting. What if I want a potentiometer? This is the potentiometer, like a photoresistor symbol. And I want the shunt resistance. So this is shunt resistance. There's a resistor small symbol. So you have this symbol right here. So you can see that. Let me increase the screen here. And you have, let's check what other symbols you have. This is variable register. This is a register small US symbol if you want this one. Symbol, small symbol if you want US symbol. This is a passive device, and this is the symbol for that. This is a variable register symbol and variable USA. Then you have a thermistor, varistor, everything is there, right? So that is how you actually can see for the register. You have so many options. So just click enter on the register. Let's go again, do that, add symbol, and type the register. And just we'll see what things you want. So this is what we want, register small, for example, and register US small. So double click it and place control, not the control, but just place on the screen. So you are done with that. Just press escape from the keyboard. Now you see you can't see that symbol actually. So if you zoom in that portion and just click here, zoom in the screen. So you actually have this register. Right click it, and you see that you have variety of options to manipulate it. And you have a data sheet for that also. Let's see about adding a capacitor. So you just type CAP capacitor and just write full then capacitor. Does it come? It came like low noise regulated charge pump IC. But where is the capacitor then? You have to find that out. Yeah, here it is, like capacitor, power management capacitor, and all those things are there. So what about the capacitor? Yeah, here, unpolarized capacitor. You see, if you want feed through capacitor, polarized capacitor, etc. So for example, you just select that. Here also you have capacitor symbol, unpolarized small symbol. You have one trimmable capacitor, you go that variable capacitor. So a lot of option. So let's say unpolarized capacitor, double click it and place it somewhere like there. Now you want to have a ground. So add a power symbol right here somewhere. So power symbol, uh, special power flag symbol specialized for spice circuit simulation, including ngSpice. So this is quite useful tool right here. For example, you have, this is a power symbol. 1 volt ground level with name 1 volt 1 V2 and so on. You have this 5 volt also, right? So let's say 5 volt, we want 5 volt, that's it. And one is ground, you want ground symbol. So where is that? We'll check that out. So you have like ground here. Okay, so this is how you do that. Then you have VCC, VTG, everything is there. So for example, you have VDD. Okay, what about you have a power source? Let's say you go to, I have clicked the choose symbol again, and let's say the voltage. We want a voltage source, or for example, you have this multi-cell battery, which is what you want. You have a voltage divider network also instead, if you want ready-made voltage, and then you have these diodes, and for which the symbols and everything is there. So what about we have selected the voltage, right? So where is the voltage? Yeah, here the battery. Then that's it. So you have a DC power supply. So let's double click it, and let us say I place it somewhere, and I don't want that. Instead, I want to cut some option. For example, where is the wire? For example, is it add a wire, and below is the bus actually. So click here, connect the capacitor. Click here, connect the resistor. Then connect to the ground. Connect to the ground. Again, connect the capacitor. Then you go and connect to this one. What to do with this symbol here for the voltage source? So edit schematic setup, including annotation. No, we want to get rid of this. So what you will do is edit, cut, Control X, and just select that and click enter. Is it cutting it? No. Just cut it like this, right click it. Now you want to do the center in the screen. So zoom, right click and then zoom and click one. So again, you have done that. So again, right click, click zoom. So let's say you want to increase the zoom. So click it 3. So depends on how much zoom in you want. Okay. Now they say you want to simulate the circuit in Spice. For example, right click the battery, and you have a properties. Click right click on it, and the property symbols came in. The value of the battery actually show. The value is, let's say, 1 volt. Okay, and or let's say 1 volt. Now right click this, again go to properties, and the value is, let's say, 1 micro. Click OK. Let's say you have a register, go to properties, and the value is, let's say, 1K. Click OK. Now you want to save it, just click save. So that's your project one schematic is done. So instead of, let's say, a capacitor 1 volt and the battery is 1 volt, so what is the voltage and the currents in the circuit? So resistor and capacitor 1 volt. So capacitor will act as a open circuit after it is fully charged. So all voltage will appear across the resistor and the capacitor. And we'll just see this symbol, simulate circuit in Spice. Let's click it. And we haven't specified any analysis yet. Add a signal and on that. So click sim command. So you don't really have that. Then file, simulations, zoom. So in the simulation, you show the spice netlist. You don't really have that one. So close it. Explore what else you can do. Edit view, place, inspect electrical rule checker. So you can basically see whether you have done any mistake while connecting the. So click here. Now electrical run checker. It is then asking run ERC. So run that, and it says input power pin not driven by any output power pins. So you are basically connecting this ground pin here and symbol for the hidden pin guard power line. So you don't need this basically because you have connected the battery there. Maybe just close it, and go to this portion, just right click this and cut. Once that is done, save it and then go to tools, no, inspect and run electrical rule checker. We'll see now, and run ERC again. You see now there is no error for the ERC, and you have actually the spice model issue has been ignored, and that's it. You don't have any error for the connections. So now with that said, you go to simulator, for example, and you see like show spice netlist error reading simulation model. You don't really have the spice model yet, so close it, then go to tools, update PCB from schematic. We don't need that right now. We have actually done that. Preference, help, getting started with KiCad. You can actually take the help also. So rotate selected items, flip items. Now this is all creating symbols and all that. Fill in the schematic symbol, perform electrical rule check. So which we have done actually, and close it. Now this is the simulator that is asking the so if you click the sim command file, let's say new plot, go to new plot. Okay, so you don't have that actually. Now what else you can do? This is the measurement, like you can use inches, millimeters, and mm. Then this is your toggle display of hidden pins, and that's your toggle automatic annotation and all that things. What about your right click and zoom in this portion? Now you actually can export this drawing to the clipboard. So when you do that, you can also export the netlist. So let's click the netlist, KiCad, OrCAD, PCB, CAD, star, spice, and the spice model. So you can export the KiCad netlist and just click export netlist, and it asks you to save somewhere. So in the same project folder, you can say like netlist with it will be saved as a type.net project one, save it. And if you want to run that or open that, so go to your stored folder. For example, just click file and or go to view, maybe no, place, inspect tools. No, you have to go to your computer folder. So I'm clicking this folder option here, And you can see on the screen, I got this folder and I have to check what is where is my folder. So it is like in the D drive. I have this my key files KiCad. In this you have project one, and this is your .NET file, right? So you see automatically it is creating your PCB file, schematic file, and this is your .NET list. So double click it and see what it opens. So for example, I want to open it with, let's say, another notepad. So we'll see what kind of netlist it goes. This is your export version. It shows what kind of things you have. Okay, what about I go to file and export the netlist, and I choose the spice, use current sheet as a root, save all voltages, save all currents, execution of the compression command successfully. It is not able to read the battery model actually. There is no model for the battery. So okay, so far you just saw how you can create the schematic from the KiCad, get the different library symbols, introduce you. We'll continue with this exploration as we move forward. So share it with others and stay tuned. Wish you happy learning.